Welcome to Ask and Learn.
In this problem, we have a block that's being moved to the right by some force in some kind of pulley system. We're given a few pieces of information, so we know that the mass of this block is 150 kilograms, and that this block experiences two types of friction. So static friction when it's sitting there, and then kinetic friction once the block begins to move. So the coefficient of static friction is given as 0.5, and the coefficient of kinetic friction, 0.4. We're also given the force from that pulley, which is 60 t squared newtons. And we want to find the power that this block generates after 5 seconds. So t is equal to 5 seconds. So we know that power is equal to the force that's being generated times the velocity. But this velocity we'll call v2. This is the velocity during those 5 seconds. So after the block begins to move, because initially it's at rest. So to find this velocity, we can go back to the diagram. We can call S1, S2 for the lengths. So we can say for the lengths, we can say S1 plus S1 minus S2 will give us some kind of length. This is the length of the entire rope. And if we do the differences for each one, we have delta S1 plus delta S1 minus delta S2, and the difference of the length will just be 0. And if we divide each one by delta t, we get, so these add up, delta S1, delta S1, so we have 2 delta S1 divided by delta t. And this is a negative delta S2. We can move this to the right, so this is equal to positive delta S2 delta t. And these are actually velocities. So this becomes 2, we'll call v1, velocity 1, is equal to v2. So if we can find the initial velocity as soon as the block begins to move, then we can find the final velocity. And since we have force, then we can easily find the power. So to find the initial time, we need to first create a free body diagram of the forces involved in this block. So we know we have weight straight down, and the weight is mg, and in the opposite direction, we have the normal force. And to the right is that force due to the pulleys, which is pushing to the right, and we know that there's some kind of friction going in the opposite direction. And in this case, right before it starts to move, it's friction, static friction. So we have mu s times Fn. So now initially, let's look at the forces. So initially, we will have 2F, since there's 2 pulleys, minus the force due to static friction is in the opposite direction of the force due to the pulley. So you have minus us times F of n, the normal force, is equal to, and then initially there's no movement. So the acceleration is 0. So solve, put this to the right side. So you have 2F is equal to us Fn. And we know, just by looking at the diagram, to find Fn, the only other force in the y direction is just mg. So the normal force is just mass times gravity in this case. So now let's plug in what we know. So 2 times F, which F is given as 60 times t squared, It's equal to mu s, which is 0.5, and the normal force, which is the mass, 150 kilograms times 9.8. So now we're solving for time. Once we find time, we can find the velocity initial. So if we solve for t, we get t is equal to, so this whole right side divided by 2 times 60, which is 20. So 0.5 times 150, 9.8 divided by 120, all of that square root. So time initial 2.4 seconds. So now we can repeat this calculations after, or as soon as the block begins to move. So again, we still have 2F minus, and then now since the block is moving, the friction is now kinetic friction. So we have mu k times Fn. Fn still remains the same, mass times gravity, is equal to, now that there's movement, the right side is the mass times acceleration. So we want to solve for A. So A is equal to, so we have 2, and then F is 60 t squared divided by M, which we know is 150, minus, and then coefficient of kinetic friction is 0.4 times, and we know that the normal force is mg, mass times gravity, so the mass is canceled, so we're just left with gravity, 9.8. So this leaves us with A is equal to 0.8 t squared minus 3.92. Now what we're looking for is the initial velocity, and we know that velocity is equal to the integral of the acceleration dt, and we know that the bounds are this initial time that we found, 2.4, to the final time, 5. So again, we have the bounds 2.4, 5, in the acceleration, which is 0.8 t minus 3.92 dt. So taking the integral, we get 1/3 times 0.8 t squared minus 3.92 times t, and then the bounds 2.4 to 5. So then when we plug this in, we get, for the initial velocity, which is v1, is 19.38 meters per second. So now that we have the initial velocity, we can find the final velocity from our equation we found, which is 2 times v1, which we found, 19.8. And so for v2, we get 38.76 meters per second. So finally, since we have the final velocity in at those 5 seconds, we can find the power. And again, power is equal to that force that's given, just 60 times t squared, and the t is the final time, so 5 squared times this velocity we found, the final velocity, 38.76. And so the power that's generated in this movement is 58.1 kilowatts.